Hello and welcome to Electricity with Mr. Bradley. You join me in my shed today and we're going to learn a little bit about electricity. Okay, so to start off with then, an electronic circuit is going to need a power source, in this case a AA battery. Fairly standard, it has a positive connection and a negative connection. You can usually see the plus and minus. This one's only got the plus, and you can see because it's raised. So this one battery gives off 1.5 volts. We'll worry about that a bit more later on. With the battery, we need to connect it up to what we call a load. Now, this could be a light bulb, could be a motor, could be a buzzer. I'm going to stick with a light bulb for now. So I've got my light bulb, in this case an LED. Now, only difference between a light bulb and an LED is a light emitting diode, which means it cannot run in different directions. It has to be wired up a particular way. An ordinary light bulb, you can wire it up to the negative, the positive, and it will still work. Now, an LED will only work if you wire it up the correct way. Let's find out how. Now, with batteries, there's a few different ways that you can wire them up. Here, for example, we have them in series. You can see we have positive, negative, and then this would connect to the positive and then negative. We then wire the rest of the circuits around. Or, what we can do is we can wire them in parallel. If we connected the wire to join up both the positives and then around to both the negatives, that's the different way of wiring it. Now, the difference between these two, you might think, what's the point of them? Well, if I wired them up this way, remember, each battery only gets you 1.5 volts. If I did this, I can do it with as many batteries as I like, and I'll always get 1.5 volts, but it will last twice as long because there's two batteries. If I wire it the other way, like that, it will last the same amount of time, but it will double the voltage, so I'll actually get 3 volts from my LED, which is what I want because I want it to show up. So what I've done is put the batteries into a battery holder. You've probably seen these before. This immediately puts them into series. So instead of 1.5 volts, I've got 3. And now all I need to do is wire up the rest of my circuit. So I'm going to take a crocodile clip and wire up. Okay, so I've got the start of my circuits. I have my batteries wired in series. I've got my crocodile clips. One going around that way and one going the other way. But of course, at the moment, the circuit is not complete. It still needs the load. So if I take my LED, and we're going to wire that up to the circuit. So I've attached the LED to the crocodile clip on one side, and now I've connected the other. Watch the LED. It lights up, perfect. And I can make a simple switch using that crocodile clip. Because all the switch is where you break the circuit. At the moment, it goes all the way around, travelling through. So if I now break that circuit, it comes off. It switches off. There we go. So now what we have is a simple switch. I thought just pressing the metal together wasn't good enough, so I got out one of my fancier switches. All I've done is added an extra wire and connected it to the switch. Now, inside the switch, simply a break in the circuit. At the moment, that circle shows that the circuit is not complete. The line means the electricity can go straight through it. So if I flick that, the LED comes on. But that's still too boring. We can do better. That's better. Now we have, borrowed from my nuclear command center, a switch where I have to turn a key in order to switch the LED on. If I just borrow the key a moment, you can see. Yeah, so I can take that with me, and now if I ever want to switch my circuit on, I can turn the key and the LED comes on. Had enough of the LED, I turn the key off and take the key away with me. Now, the LED I was using already had some wires attached to it and all soldered in, but I thought you might be interested to see what they actually look like before they get played with. So, this is a different LED. Only main difference is this one is, yes, you guessed it, it's blue. And if you look carefully, the two prongs coming out, one is ever so slightly longer than the other. Now, this is important because it helps us figure out which one we wire up to positive and which one we wire up to negative. You might remember I said that they'll only work wired up one way. Don't believe me? I'm going to show you. So I've simplified things a little bit, taken out the crocodile clip wires. I'm going to connect directly to the contacts on the battery. Let's try it one way. Nothing happens. Oh dear, must be broken. No, 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 no. Let's flip it around. And now that works. Just move my thumb out the way. There we are, so that's lighting up but only in one direction. Now the only reason it's flashing ever so slightly, partly because of a special effect on your screens, it can't keep up with it, but also because the connection isn't terribly good. I just need to press it a bit harder. There we go. Well, that about wraps it up in the shed for today. I hope you've learned something useful, and I'll see you all next time. Bye.